So let us start with question number, with section B, question number 2. Section B, question number 2. Just try this yourself. So go through the question and try it yourself. I'm just putting up the diagram and all on the board. So position versus time graph for two children A and B returning from school to their homes P and Q are shown in the figure. Okay. So this is obviously assuming that A and B move along a straight line. That is the x-axis. And that straight line is nothing but the x-axis. So assuming this, the graph is given to you. That if this is your x coordinate versus time. A lot of these type of questions we have done in the beginning, you will remember the first few lectures that we did. So now we are just looking at some practice examples of all that stuff. So the child moves along this kind of a path, and the child B, his x coordinate is given this kind of something like this kind of a graph, and also P is this point and Q is this point. So what is given to us is that A goes home from school to the P, okay, whereas Q goes home from school to Q. This information is given to us. And O is the position of the school. So based on this, we have to check out which option is correct. Find the correct entry or entries in the brackets below. Oh, sorry. Yeah, my mistake. Thanks. So B goes home to school. That's correct. Thanks for pointing out. Yeah, so is the meaning of the question clear? Thanks, Athirva. Okay. So therefore, we have to be very careful about the language of the question over here. Okay. That suppose in the graph, the coordinate of x, the point P is having x coordinate equal to x1, suppose. Okay. And the point Q is having x coordinate equal to x2, suppose. We can see that x2 is greater than x1. Okay. Now, what about the school? The school is having x coordinate equal to 0. It's not like the school is having some other x coordinate for B and some other x coordinate for E. School का x coordinate मुझे दिया हुआ है because it is given that from the school O to the point P, that is the motion of E, and from the school O to the point Q, that is the motion of B. Okay. So this is A's home and this is B's home. So what is happening? It's very clear to us that A is moving from school to his or her home. So he or she is moving from x equal to 0 to x equal to x1. So what is the path? He is moving through a path. Change in x coordinate of A is x1. This is A's path. But similarly, B is moving from school, mind you, not from some other position. So he is moving from school to his or her home. हाँ, भौमिक D कहाँ लिखा है बाबा? 0 लिखा है सिर्फ. So स्कूल क्या है? X equal to 0 है. और B का home क्या है? X equal to X2 है, which is basically the point Q. So what is the change in position of B? This is delta. This symbol is delta. It means change. So if we say delta T, it means change in time. If we say delta X, we mean change in X. Okay, is that clear, Bhavik? Okay, so coming back to this, B's path is how much? It is X2. This is the path traveled by B. Okay. So that is one thing you can see. The other thing you can see in the graph is that if you analyze this graph at t equal to 0, at time t equal to 0, A is at x equal to 0, that is at school. Okay. But B, okay, we don't know. We don't know where B is because B's time is starting from somewhere else. So let us say this time is some t1. So whereas at time t equal to t1, where obviously t1 is greater than 0, what about A is at some x which is greater than 0. You can see that A is at some coordinate which is greater than 0, but B is at x equal to 0. Okay. So this is also something you'll have to keep in mind while looking at the options. Okay. So just note down this information based on the graph and now tell me which options will be correct. Okay. Go through this, note down this information and tell me which options will be correct. Bhavik, hope you understood the meaning of the symbol delta over there. Okay, Vanishka, let me explain with an example. Suppose ये graph में मुझे कुछ values दिए होते, okay? So let me explain in detail. Suppose this graph was actually something like this, where it's the same thing, but I'm just assuming some values. Okay, Vanishka. So it is the x versus time graph, where this is how A was going, and this is how B was going. So I'll label everything, but so just give me a second here. This is the path of E. Okay. That also, that's something interesting. We can see that B is overtaking A and all that. Okay. But before all that, okay, this is the time axis, this is the x-axis. This point is the origin. Okay. And also, given that P and Q are some coordinates like this, where in the graph originally P was the smaller one, Q was the larger one. So P is A's home, that is P, and Q is the coordinate where there is B's home. So let me take some values. Let me assume, for example, that this point in the graph, suppose, is, let us say this point is 2 minutes. Okay. And let us say this point, let us say 5 minutes. Just I'm saying, suppose. and this point, whatever, let's say 5 kilometers. This point is, let us say, some 7 kilometers. This point is, let us say, some 8 kilometers. Okay. Now see, Ishka, what is happening? Now is graph mein, before we start analyzing, what is the information given in the question? Information given apart from the graph is that A goes from school, which is the origin, which means x equal to 0, okay, to home, his home, his or her home. जो कि कौन सा point है? It is the point P. So the x coordinate at that point is how much? According to my graph, it is 7 kilometers. Okay. And B similarly goes from school, not from somewhere else, which is again the origin only. So x equal to 0 to his or her home, which is the point Q. So that x coordinate is how much? 8 kilometers. Okay. So is this clear? Oh, okay. I have understood wrong. Okay, D is the option. So I'll check and tell you. Right. So now मैं क्या बोल सकता हूँ यहाँ पे कि A's path, okay, the total path length is how much? It is x equal to 0 to x equal to 7. So it is 7 kilometers. B's total path is how much? It is x equal to 0 to x equal to 8 kilometers. So that is how much? It's 8 kilometers. So which one is traveling more? Therefore, B travels a longer distance. I'm not interested in time right now. I'm just saying that which one travels more distance. It is B. Okay. Now, one more thing in the graph, you can see that okay, B is where at 2 minutes? He's at the school. Okay. So he's traveling from the school starting at 2 minutes and reaching his home at some other time. Okay. Whereas A is starting from the school at t equal to 0 and reaching his home at some other time. Okay. So you can also see that suppose this time is something and this time is something. So this is, let's say, some t1, let's say some t2. So what is happening here? Of course, the graph should not go beyond it because B goes home and stops. So again, from the graph, you can see that E is traveling from 0 to t1's time. So E starts at t equal to 0 from school and is home at t equal to 2. Okay. Whereas on the other hand, B does not start at t equal to 0. B starts at t equal to 2 minutes or some arbitrary time, let's say that is some t naught. I have assumed in this graph that time is t naught, but we can just assume it's some general value t naught. Okay. But definitely greater than 0 and is home at, so home is at the point Q, but at what time? At t equal to t2. So A is traveling for how much time? So A is traveling for t1 time, whereas B is traveling for how much time? T2 minus 2 minutes or T2 minus T1 amount of time. Okay, is this clear? So now from this I can see that in the graph, now already T1 is greater than T2. I can see the graph. So definitely this time interval is greater than this. So since T1 itself is greater than T2 from the graph. Okay. So definitely I can see that T1 will be greater than T2 minus T1. Definitely this will be the case. That means what is happening? This means that A is traveling faster than B. Although A is traveling for less time. Okay. We can say that A is reaching faster. For shorter time. A is traveling for shorter time. But then A is also traveling a shorter distance. You can see that also. At the same time, A is also traveling a shorter distance. B travels a longer distance, but A is traveling for lesser amount of time. Okay. And now one more thing you can see in the graph is that at the point of time 5 minutes, which suppose I write as P prime, okay, they are crossing each other at, let's say, the coordinate x prime, which is 5 minutes. So kya ho raha tha? Before 5 minutes or before T prime, whose coordinate was smaller. So you see at any time before this, at a time like this, or at a time like this, okay, what was happening? B's coordinate is less than A's. The blue line is below the, so what is happening? So we can, the third thing we can see from the graph is from P equal to 0 to T equal to T prime, which I have taken in my graph as 5 minutes. The x coordinate of A is greater than the x coordinate of B. So that means A is ahead. Aage B. But at T equal to T prime, which I have taken as 5 minutes, what happens? B overtakes, because the x coordinate of B becomes greater than the x coordinate. So that is the other thing. So all this information we are getting from this graph. So now we can see essentially what all information I'm getting from this graph. I'm getting the information that overall A is traveling less distance than B. Okay. But A is traveling for longer time. Sorry, B is traveling for longer time. So it is also traveling in lesser time than B. And I can also see that B overtakes E at some time. Let's see that is. Okay, beta. Yeah, that's okay, Vanessa. So that's the purpose of this exercise, that we will understand how to do questions in a lot of detail. So that's why we are taking up this lecture today. Okay. So that's what this graph is the same as the earlier graph. There's no difference between this and this. Okay. But here I've just explained in more detail by just taking some values. So जो भी useful information है वो यहाँ से आ जाएगा. Okay, people. So hope this is clear. Yeah, you guys, I will scroll up. So basically, you need this information. Okay, so first go through this graph in detail, and then I will again zoom out so that you can write down all the information. Okay, so just write all this down first, then I will tell you how to match the options. Yeah, I'm giving you the information for question 1. So now this is all the information that we get. That A goes from school, which is the origin, to his or her home, which is the point P, which I have assumed is 7 kilometers. It's not given, but I have just made a wild assumption that this is 7 kilometers and this is 8 kilometers. Okay, Yuvraj, this is the information in the question. So immediately by analyzing the x coordinate of the point P and Q, so going back to the graph, you can see that which point is above, Q is above. That means the distance from school to Q, which is this vertical coordinate, which I have taken as 8 kilometers, is definitely more than the school, which is O, to the point P. So किसका घर ज़्यादा दूर है? B का घर ज़्यादा दूर है, because Q is further away. So that's the information. Okay, that's the information we are getting, that B is traveling for a longer distance. Okay. Now next we analyze it for time. So for time, देखो क्या हो रहा है यहाँ पे? A is reaching his destination, which is the point P. Which is the point Q. Just a minute. A is reaching the point, which is his destination. So A's destination is not Q. A's destination is the point P. Okay. So this time will be something else. My mistake. The time T1 will be this time. Because A का destination क्या है? A's destination is not the point, that one. Okay. Let me just magnify this graph. So A's destination, now A is, remember, the red colored line over here. So A's destination is which point? The point P. So A is reaching his destination at this time. So let us say this time is some T1. Okay. Whereas you can clearly see from the graph that P is reaching his destination, which is this point Q, at some time T2. So we can see that T1 is greater than T2. So now you can see that A is traveling from T equal to 0 to T equal to T1. So total कितने time के लिए travel कर रहा है? A is traveling for a time of T1, whereas B is traveling from when to when? B is traveling from this time, which I have taken as T0, or 2 minutes in my graph, to T equal to T2. So B is traveling for a time interval of how much? T2 minus T0. So that is how I can see that the time for which A is traveling, delta TA, which is basically T1, is greater than the total time for which B is traveling, which is T2 minus T1. That I can definitely see from the graph. Because anyway, T1 is greater than T2 and B is traveling for even less than T2. Okay, so from the graph, I can see that T1 is greater than T2. So definitely it implies that T1 will be greater than T2 minus T1. T0 being the time when B starts. So that's how I'm making my second statement over here, that as far as distance is covered, that was my first statement. कि distance कौन ज़्यादा travel कर रहा है? B. But time किसके लिए ज़्यादा है? A के लिए ज़्यादा time. Okay. So that is the statement over here. That A starts at T0 and reaches the destination at T1. B starts at 2 minutes and reaches the destination at T2. So that means A is traveling for a total time of how much distance? But B is traveling for a total time of how much distance? So definitely this time is greater than this. So that means who is traveling for a longer time? A is traveling for a longer time. A is traveling for a longer time. And the third thing that we can see from the graph is this, that when the graphs are crossing each other, what is happening? One of them is overtaking the other. So one of them is overtaking the other. Which one is overtaking? So you can see that before this time when they cross each other, which graph was above? A's graph was above. So that means XA was greater than XB. And then after this time, what is happening? XB is becoming greater than XA. So that means B is the one that is overtaking. So at some interval of time, or at some value of time, at a certain instant which we are taking as this 5 minutes or t prime, what is happening? B is overtaking. Okay. So that is the other statement, which is over here. Okay, so now with all this information in mind about the graphs and all that, let us quickly go through the options and make a choice of which option that. Okay. So option A मुझे क्या कह रहा है? Option A बता रहा है that B lives closer to the school. Than A. We can see that that is not true. That is not true. Why? Because we have seen that the x coordinate of Q was greater than the x coordinate of B. So B's home is further. So B's home is actually further than E. So that means this first statement is wrong. Not. Okay, then let's go to option B. It says that B starts from school earlier than E. So again, we can see this is a wrong statement because we had seen in the graph above that what was happening. If we saw in the graph that A started at t equal to 0, whereas B started from the school at t equal to some t prime, which I had taken as 2 minutes. So actually B started later than A. So you can clearly see that this statement is wrong. Now the next option, let's see what it's saying. So it says that A walks faster than B. Again, this is wrong. Because we can see that what is happening, actually B overtakes A. And that too, he not only overtakes, even though B starts later. So एक तो A को head start भी मिला है because B has started at a later time. A started at t equal to 0, whereas B started 2 minutes later or something like that. But in spite of that, B overtakes A. So definitely B is traveling faster. ना? एक तो overtake भी कर रहा है, ऊपर से B started later also. So definitely we can say that B is traveling faster than B. So that means only one option can be correct. So let's check what the D option is saying. So saying that A or B overtakes B or A on the road once or twice. So this is like a conditional statement. So what you can actually see here is that this is the correct statement because we can see that B actually overtakes A once. Okay. So since the statement is conditional, okay, you want me to explain the option B? Okay, Bhaumik, I'm coming back to that. But are you clear with option C and D? Yes, Bhaumik, beta, are you clear with option C and D? Oh, so let me come back to option B and explain. So B option क्या कह रहा है that B starts from the school earlier than. But if you go back to the graph, let's go back to the graph. You can see here what is happening. Now A is, remember, the red line. No? So A कब start कर रहा है? A is starting at time t equal to 0 from the school. Whereas B is starting when? At 2 minutes. So which one is starting earlier? A is starting earlier. No? A is starting when the clock reads t equal to 0. Now let's say A has started his stopwatch when he starts from the school So t equal to 0, A का motion start हो गया. Already started moving away from this. But what about B? B is at the same coordinate for that much time. Na? He starts from the origin. Okay. Yeah, A has started at t equal to 0. But what about B? When has B started? 2 minutes पे ना. Alright, Bhumik, understood this point now? A ने तो 0 पे start कर दिया, but B ने कब start किया? उसके बाद में start किया ना. So who has started earlier? A has started earlier. Whereas what is the statement saying? That the option is saying that B starts from school earlier than A. So it becomes the wrong option. Option B is saying that B starts earlier. But actually what is happening? B is starting later. Okay. So let's just wait for Bhumik to rejoin. I think he's having some trouble with his internet connection. Okay, anyone else has a doubt with any of the options? Okay, so people, if the options are clear to you, next we will move on to question number 4. Okay, so try out question number 4. Okay, if the options are now clear, Adinath, I'll explain option D. So option D, देखो क्या कह रहा है, that option D is a very tricky statement. Okay. Option D, what it means to say is that either A or B, this is the meaning of A slash B, okay, overtakes B or A, that is either B or A at 1 or 2 times. Okay, so this is a very tricky statement. What this means to say is that there are many cases possible. Okay, it means that either A overtakes B once in the motion, okay, or A overtakes B twice in the motion, okay, or B overtakes A once in the motion, okay, or B overtakes A twice in the motion. Okay, so that's why I said it's a very complicated statement, because it's a conditional statement. उसका मतलब देखो, ये चारों में से कोई भी condition correct होगा, so we can say that option D is correct, because it's talking about or, it's not talking about and. Understood, Adinath? Is this language clear? You understanding how this statement is basically a set of these conditional statements. It's saying A slash B overtakes B slash A at once or slash 2 times. ठीक है, so it's a very complicated statement. इसका मतलब क्या होता है कि हो सकता है A B को overtake कर रहा है एक बार, हो सकता है A B को 2 बार overtake कर रहा है, हो सकता है B A को एक बार overtake कर रहा है, हो सकता है B A को 2 बार overtake कर रहा है. So all these different possibilities are there. Now we are seeing actually from the graph which one is correct, that B overtakes A and that too only once. So only this statement is correct. These statements are actually wrong, but because it is or, so that means the statement D is becoming what? The statement D is becoming correct. Okay, so this is clear. Yeah, Bhomik, are you back in the, yeah. So Bhomik, is your connection all right now? Bhomik, can you please send me a message to confirm, is your connection all right now? Okay, Bhomik, hope you are receiving this. Now I'm going back to option B, which you wanted explanation for. So option B, देखो क्या बोल रहा था, that B starts from school earlier than A. Whereas you can see clearly that that is not the case, because what was our graph showing us? Our graph was showing us that the motion of A was like this. This was the motion of A. So that means what is happening? A's motion is starting at t equal to 0. So A is starting at t equal to 0 from x equal to 0. But what was said about B? Okay. B के बारे में देखो क्या दिया हुआ था क्वेश्चन में. This sort of a graph was given for B. So as far as B's motion is concerned, what is happening? It's not starting at 0. It's starting at some time t prime, but it's starting from x equal to 0. Okay, so B is starting at t equal to t prime, but obviously from the spool only, from x equal to 0. So which one is starting earlier? You can see. So therefore A starts before B, no? Not the other way around. And what was given in option B? That B starts before A. So that's why that option became wrong. So Bhaumik, if you are able to follow all this, I'm seeing you are back in the group, but I don't know if your connection is all right now or not. So if you can please confirm via message that you understood this. Okay. Otherwise, I'll explain it to you again, Bhaumik. Meanwhile, others, if you can please move on to question number 4 now. If all the options are clear to all of you people, please move on to question number 4 of the same exercise. Okay, question number 4. It's on the next page. Yeah, Bhaumik, see here in the graph what is happening. A का motion क्या है? T equal to 0 पे वो origin पे है, और origin से वो its x coordinate is increasing with time as time is increasing from 0. That is the red colored line. It is the x coordinate of A, how it is changing with time. So you can see that at t equal to 0, A is here. At some positive time, it's here. At some other positive time. So it's continuously, its x coordinate is increasing with time from t equal to 0. But what about B's motion? B's motion is not starting at t equal to 0. No, B's motion starts here at this time t prime. So B is not at all moving from 0 to t prime. His motion is only starting after t prime. Then only his x coordinate starts increasing. So that means B का motion चालू कब हुआ है at t prime. A's motion has started when? At t equal to 0. So who has started earlier? A has started earlier. Na? Is it clear now, Bhaumik? Okay, Adinath and Dhruv, good. Okay, good. So let's come to question 4. Yeah, Adinath and Dhruv, you can just check your calculation once, but you got it correct. Okay, good, Bhaumik. Okay. So let me explain question 4 for the others also. So what it is saying is that a person is traveling along a straight line, moves with a velocity v1 for some time, and then v2 for an equal amount of time. Okay. So a person is traveling along a straight line. So what happens is he travels with v equal to v1 for time 0 to t equal to some t1, let's say. Okay. Then he travels at v equal to v2 for t equal to t1 to how much time? T equal to same amount of time. So that means this will become twice of t1. This will become 2t1. So for example, if we traveled at v equal to 30 meters per second for t equal to 0 to t equal to 5 minutes. So he's traveled for a total time of how much? 5 minutes. The interval of time is 5 minutes. Now he's traveling at some new speed, let's say 40 meters per second. But for how much time? The same 5 minutes now. So he will now be traveling from time 5 minutes to how much time? 10 minutes. So that the interval of time is how much? This delta t is now again 5 minutes. Okay. So that is why if this is some time t1, this will have to become 2t1. So now we have to find the average speed. So average speed क्या होगा? Average speed will be total distance upon total time. So the total distance will be what? V1 into T1 traveled in the first part, but again in the second part is traveled how much? V2, but into the same amount of time. Whereas the total time is how much? T1 plus T1, so it's 2T1. So as you can see, it is V1 plus V2 into the common factor of time T1 divided by the total time, which is 2T1. So this is becoming how much? V1 plus V2 by 2. Okay. So this is becoming his average speed. This becomes the answer for this, which is option A. Okay, students, so hope this is clear to all of you. Okay, we're done. Now let's come to question 5. Yes, Bhageshji, what you have solved is correct. Very good. Okay. Rest of you go through the language of question 5 and try it. It's okay, Bhomik. I will send you the recording for the part you missed. Don't worry. Okay, just concentrate on the question now next. Okay, don't worry. So next question number 5, people. Just go through that, please. Question 5 of the same exercise. It says that a body moves through a certain distance at speed v1. Then it moves same distance but at a uniform speed v2. So this is also a uniform speed. This is also a uniform speed. So we have to find the relation of average speed v with v1 and v2. Okay, this is what we do. And we have to mark the options. Okay. So again here, okay, let us assume that the total distance traveled is x. Okay, that initial distance. Okay, so let the distance traveled at speed v1 is equal to x. Therefore, the distance traveled at v2 will also be x. Okay. So therefore, total distance traveled will be equal to 2x. Okay, because he's traveling x at v1 and x at v2. Okay. So therefore, the average speed v will be how much? It will be total distance upon total time. Okay. So now see, what is the total distance? It is 2x. Whereas we can write the time t1 plus t2. Okay. Now what is happening? If this distance traveled is x at speed v1, so what is the time taken? It will be x by v1. And if this distance is x at v2, what is the time taken for this distance x? It is t2 equal to x by v2. So now I can replace in this, I can replace the total time t1 plus t2 as how much? X by v1 plus x by v2. So what is the relationship I have now? That v is equal to 2x upon x into 1 by v1 plus 1 by v2. So what I can do is, I can write it like this, that v is equal to 2 times v1 v2 upon v1 plus v2. Okay. Or I can write it like this, that v by 2 is equal to 1 upon 1 by v1 plus 1 by v2. I can also write it like this directly from here. So invert this now. So 2 by v is equal to 1 by v1 plus 1 by v2. This is also correct. So this is how we solve a problem like this. Okay. So you people have solved this correctly. It's just that you have to further, algebraically solve it to match one of the options. So if you've got to this point where you, yeah, I've done that. Vanishka, you're not able to see this. Sorry, Vanshika, you're not able to see this right now. Okay. So I will give it to you in two parts then. Okay. So the first part was this. This is the question, and now this is how I set it up. That suppose let, this is an assumption. Okay, so let or assume the distance traveled at the speed v1 is x. So it happens how much time t1. Then the distance traveled for the second interval at speed v2 is also x. Okay. But that is happening in how much time? t2, which is x by v2. So now based on this, so this information that I've written, this is based on the information given in the question. Okay. Now I have to calculate the value of average speed. This I have to calculate. That's where the lower part comes. So just write this down. All right. So next, this is the step. So the average speed is total distance upon total time. So total distance यहाँ पे क्या हो जाएगा? X plus x, that's 2x. Whereas total time will be t1 plus t2. So just replace those from above. So that is how we are coming to this, and this is option C in the question. Okay, now let us move on next to the 8th question. It's a graph-based question. We have in the beginning done a lot of practice of graph-based questions. So today is a bit of a test for you guys whether you can retain those concepts or not. So try this question out. So you have an acceleration versus time graph given, and you have to find the distance traveled. So acceleration versus time graph is given to us, and we have to find the distance traveled. So just start the question yourself. Try it out. I'm just putting it up on the board in the meantime. So from the graph, you can see that from 0 to 5 seconds, the car has a uniform acceleration, let's say a1 of 2 meters per second square. From 5 to 10 seconds, you can see that acceleration of the car is 0. And then from 10 to 15 seconds, the acceleration of the car is minus 2 meters per second. And it is also given that the car starts at t equal to 0. So the fact that it starts means that its initial velocity is 0 at t equal to 0. You have to find the total distance. From 0 to 15 seconds. So I've given you some shortcut methods and all that also to discuss, to try out these type of questions. So just try to recall that what are the different methods by which we can solve a problem like this, and take a crack at this. नहीं बेटा ध्रुव, that is not correct because area under acceleration versus time graph is not displacement. Okay. The area under acceleration versus time graph is not displacement beta. The displacement is the area under the velocity versus time graph. Which graph is given over here? Acceleration versus time. Yeah, Bhomik. Sorry, Bhageshri, correct. So this is acceleration versus time graph. Keep that in mind. This is not velocity versus time graph. Given to you here is the acceleration versus time graph. So if you're trying to calculate the displacement by area, convert this to a velocity versus time graph. Okay. Displacement is area under the velocity time graph. Good, Yuvraj, that's correct. Bhomik, you have to be more specific. You have to give the exact answer. Okay, so let us try and understand the easiest way of doing this question. Yeah, Anshul, what you're saying is correct. So the easiest way of doing this question is that you convert this given graph into a velocity time graph. So how would the velocity time graph be? From the given acceleration versus time graph, how would the concerned velocity versus time graph be? Let's try to understand that. So acceleration in meter per second square, time in seconds. So the first part of the motion, which is happening for the first 5 seconds, is happening with uniform acceleration. Over here. 5 seconds, the acceleration is 2 meters per second square. So from t equal to 0 to t equal to 5 seconds, the initial velocity was 0. The acceleration was plus 2 meters per second square. So what is velocity as a function of time? It is 2t. V is equal to u plus at. So what will the velocity versus time graph look now over here? For the first 2 seconds, it will look like this. The velocity would have increased to a value of, at 5 seconds, the value would have increased. Give me a second. Yeah, so the velocity would have increased to a value of 5 to the 10 meters per second. By the time the time has gone to 5 seconds. Okay. Then what is happening in our second part of the motion? The acceleration is constant but at 0. So, OS, I suppose. Okay. So that is happening till 10 seconds. So during that time, from t equal to 5 to 10 seconds, the acceleration is 0. That means velocity is how much? It is constant at 10 meters per second. It's uniform velocity. So corresponding अभी ये वाला part graph में कैसा दिखेगा? It will be a straight line graph till you reach the time of 10 seconds. And then the final part of the motion, the acceleration is uniform, but at what value? A negative value. So from 10 seconds to 15 seconds, let's say that's over here. Okay. The acceleration has a uniform value of minus. So now this is the part which gets a little bit tricky in calculating. So you can see that at t equal to 10 seconds, the velocity is 10 meters per second. Okay. And then from t equal to 10 to 15 seconds, the acceleration is how much? It is minus 2 meters per second square. So the velocity is decreasing at this rate. It is becoming 10 minus 2 into t minus 10. Because the interval of time is this one. This is your delta t. So you will see that the velocity is like this. The velocity at t equal to 10 seconds is 10 meters per second. The velocity at t equal to 11 seconds is becoming 8 meters per second. The velocity at t equal to 12 seconds is becoming 6 meters per second. And like this, by the time you're coming to 15 seconds, you'll see that this delta t's value is becoming 5. So the velocity is coming to 0 actually. So, t equal to 15 seconds पे velocity का value कितना हो जाएगा? 0 हो जाएगा. So that is showing you that uniform deceleration यहाँ पे ये graph कैसे behave करेगा? It is behaving like this. It's coming exactly to 0 at 15 seconds. Now, which is my displacement? My displacement is going to be this total area. Okay. This total area that I have over here, this is going to become now my displacement. Okay. This total area. That's not very good. I made a mess of it. Some lighter color. This total area, this entire area is going to be my displacement. Okay, so hope this concept is clear. So this is how we are converting this graph from acceleration versus time to velocity versus time. Now calculate that area and you see you get the answer. $100 meters. That's correct. I'll show you other approaches also. We will do formula based approach also. Yeah, so Shobha, what we are doing here is we are converting the acceleration versus time graph into a velocity versus time graph. So देखो, I have explained each point carefully here. Just go through each of these and see how that graph is plotted. So initially क्या हो रहा है 0 to 5 seconds में मेरा acceleration positive है और constant है और initial velocity क्या है 0 है. So velocity versus time का relation कैसा आएगा? V is equal to u plus at. U is 0 and acceleration is constant at 2. So velocity as a function of time is what? 2t. So this is a straight line. The velocity is increasing at the rate of 2 meters per second every 1 second. So at 5 seconds, oh, bombing, right. So at 5 seconds, the velocity is increasing to how much? It's increasing to 2 into 5, 10 meters per second. All right, bombing. So this is clear. Now what is happening for the next 5 seconds, from 5 to 10, acceleration is 0. So that means velocity will be what? Uniform. So it's reached a velocity of 10 meters per second. It's remaining uniform for how much time? Till 10 seconds. And then for the next 5 seconds, that is from 10 to 15, uska deceleration kitna hai? 2 meters per second square. So the velocity is equal to u minus deceleration into time. But the time is what? That interval of time. No? So this is started at t equal to 10. So at any time t, for how much time delta t, the deceleration has happened. It has happened for t minus 11. Sorry, t minus 10. So that is why, for example, when you substitute the value of t as 10 seconds here, you will get the value of velocity as 10 meters per second. When you substitute it as 11, this interval of time will become 1 second because 11 minus 10 is 1. So the velocity is reduced to 8. Similarly, at 12, it is reduced to 6 and so on and so forth. So by the time you reach 15 seconds, your velocity has become 0. So that is what is showing me that in this graph, the velocity is decreasing all the way from 10 to 0 in the time interval from 10 to 15 seconds. So hope that is clear now, Bhavin. Okay, so this is the graph method of solving this problem. Now, we can also alternately solve this problem by formula method. So there's also an alternate method of solving this problem now. But before that, let's calculate the area. So the area under this graph will become how much? So this area will be half into sum of parallel sides. So this side is 5. This side is 15. So 5 plus 15 into perpendicular distance between them, which is this 10. So this is in seconds and this is 10 meters per second. This is area of trapezium. So that is half into 20 into 10. You can let's see 100, and the unit will be second multiplied by meters per second, so 100 meters. So that is becoming your total displacement. Okay, so this is the area based method of solving for the distance. Sorry, for the displacement. Here, of course, distance will be the same thing as displacement, because you can see that it's moving in one direction. It's motion along a straight line without the velocity ever becoming negative. The velocity is always positive. That means the direction is not reversing. That's another thing you can note down about this question. You understand here that here the velocity is always greater than equal to 0 from the entire time, 0 to 15 seconds. So therefore, the motion is always along the positive direction. So that means it never reverses. Okay. So that means, so therefore the distance traveled will be equal to the magnitude of displacement. So the distance traveled will be equal to S. So that will also be 100 meters. Okay. So both the distance traveled as well as the displacement, both are equal to 100 meters. Okay. So that's one additional aspect of this motion you can understand. Okay, now let's see another way of solving the problem. Formula based method. So you can see that from t equal to 0 to t equal to 5 seconds. Okay. Initial velocity is 0 and acceleration is plus 2 meters per second. Uniform acceleration. So the displacement in this interval of time, you can write as ut plus half at square. So that is 0 plus half into 2 into 5 square. So that part of the displacement is equal to 25 meters. So this is the displacement which is occurring from 0 to 5 seconds. The next part of the motion you look at, then from t equal to 5 to 10 seconds, what does that mean? The acceleration is 0. So therefore velocity will be constant. Okay. Now the question is, how much is that constant velocity? So you can see that the velocity at t equal to 5 seconds, वो कैसे निकालेंगे? For that you have to go back to the first. So for this you have to go back here and you have to understand that what was happening from 0 to 5 seconds, the velocity is given by the relation u plus at. So that over here by the formula method is becoming 0 plus 2t. So velocity as a function of time was 2t. So that's why you can see that velocity at t equal to 5 seconds is equal to how much? 10 meters per second. So the velocity is 10 meters per second and the displacement by then is 25 meters. So now you have to put that back over here. So you have to understand that this value has to be now re-substituted here. So this constant velocity is 10 meters per second for the next 5 seconds. Okay. So now we can see that displacement is equal to velocity into time. So that is 10 into 5 seconds, 10 meters per second into 5 seconds. Okay. So it's equal to 50 meters. So this is the displacement from from our 5 to 10 seconds. This is the displacement. Okay. Vanishka, are you able to see the screen now, beta? I've de-shared it. Vanishka, hope you're able to see the screen now. Yes, Bhaumik, I will send it. Don't worry, beta. Okay. So just note down these two parts first. Then we will come to the third part, which is what is happening from t equal to 10 to 15 seconds. So we'll come to this. Okay, just note this down first. This part. Vanishka, hope you are able to receive all this. Okay. In case you are having difficulty with your connection, you can try one thing. Just log out and re-log in using the same password. Oh, okay, that's good. Okay, so just note this down and now try to apply the same method beta for the third part. Okay. Just like I've used the formula for first and second part, like that use the formula for the third part also from 10 to 15 seconds and see how much displacement you are getting. So then you have to add the 3. You're getting 25 meters for the first 5 seconds, then 50 meters for the next 5 seconds, and then for the last 5 seconds, you see how much displacement is you will get. You have to add the 3, and that should come out to be how much? It should come out to be 100. Okay, so you're getting 25 meters, all of you, very good. Good. So for this, you can see that the initial velocity is nothing but the velocity at t equal to 10 seconds, which you can see from this part, because the velocity is uniform, is how much? 10 meters per second. But from the graph, you can see that the acceleration is minus 2 meters per second. And this interval of time is 10 to 15 seconds. So the interval of time is 5 seconds. So the displacement, which is ut plus half at square, in this we should substitute the time as 5 seconds, not as 15 seconds, because it started from 10 seconds. So we will get this as 10 into 5 plus half into minus 2 into 5 square. So 50 minus 25 or plus 25 meters. So this is the third part of the displacement. Let us say this is S3. Whereas this one, let us say, was S2, and this one, let us say, was S1. So our net displacement now is S1 plus S2 plus S3, which when you work out, you can see is 100 meters. Okay. So you can see it's a little bit more complicated. Doing it by formula-based method is a little bit more complicated and lengthy compared to the graph method, which is why I told you that the fastest and the easiest way of solving the problem is by converting the acceleration time graph into a velocity versus time graph. That is the easiest and sort of minimum fuss kind of method. The chances of making a mistake is very less. Okay, so this is your question number 8. Now moving ahead, the rest of the questions in this exercise are easy. You'll be able to solve mostly. Now I'm going to come to exercise 4. We'll discuss some question from this. Okay. So next up, let us move to exercise 4. Okay. On page 24. So we'll start with section A. Let's start with question number 3. We try this again. Yes, you have to do this. Try this question. Okay, so very simple question. You must have got the answer. Doubt in question number 11, section B. Okay, I'll come to that. Dhruv, I'll come to that. Correct. Bhageshi, area under the graph. Okay. So all you have to do in this is calculate the displacement is as the area under the graph. So you will see that the displacement from 0 to 4 seconds, that will become positive of that area, which will be half of sum of parallel sides. You can see will be 2 plus 4 into the distance between them, which will be 4. Okay. And the displacement from 4 to 8 seconds will be negative of that area of that trapezium. This is half of sum of parallel sides, again 2 plus 4, but this will be 2. So this will come out to be plus 12, but this will come out to be minus of 6 meters. Okay. So now we have to find the distance. So distance will be the displacement from 0 to 4, because it's a positive displacement, plus magnitude of the displacement from 4 to 8, because it's a negative displacement. So this will become 12 plus of mod of minus 6. So the distance traveled will be 18 meters. Okay, the total distance will be 18 meters, whereas the total displacement on the other hand, the net displacement, that would have been displacement from 0 to 4 plus displacement from 4 to 8. So that would have been only plus 12 minus 6 or plus 6 meters. So this is a case where you can see the velocity is becoming negative after a while. So displacement is less than distance. Good. Okay. So the only thing I wanted to bring to your notice is in this type of question, you have to be careful about the difference between distance and displacement. Okay. So this is clear. Now on the way, I'll just clear a couple of doubts some of you had. So Dhruv, you had a doubt in question number 11 of section B, exercise 3. So let's move on to that. So question number 11 of section B of exercise 3. So let's just move on to that for a moment. Then we'll come back to exercise 4. So in this beta, I will do the section on circular motion later and explain to you. So what happens in circular motion is we have something called angular speed. So as something is going around in a circle, we have something called angular speed. So what happens is in some time, suppose it is here at time t and it is here at time t plus delta t. So in that time delta t, so in that small interval of time delta t, it covers an angle delta theta. So we define something called angular speed, which is delta theta by delta t. So वो angular speed कितना हो जाता है? That is given in the question here as, now question number 11. Yeah, it is given as 3 revolutions per second. 3 revolutions per second. Okay, so that will become 3 into 2 pi in radians per second. Because one revolution is equal to 2 pi radians, which is the same thing as 360 degrees. So this is the SI unit that we use. So therefore 3 revolutions per second will be the same thing as 3 into 2 pi or 6 pi in radians per second. Okay. So this is our angular speed, 6 pi radians per second. So now we have to convert this angular speed to linear speed. So this linear speed that it is, this V, there's a certain equation in circular motion which we'll study at a later stage. So this V is delta S by delta T, whereas delta theta by delta T was given equal to 6 pi. Now since we know that delta S in a circular motion is nothing but radius into delta theta. Okay, because what is happening, delta S is a very small distance traveled. So in that circular motion, let's say, as is going from here to here as part of the full circle, this distance is delta S. So it's a small arc length, okay, whereas the radius is r. And this angle here, this angle is your delta theta. So this is the relationship between angle and radius, or angle and distance. Okay, so this is nothing but arc is equal to angle multiplied by radius. Okay, the arc length is equal to angle multiplied by radius. Okay, so Dhruv, you are understanding so far? Okay. Dhruv, just send me a message. Okay, good. So now if I divide by time on both sides, so delta S by delta T is equal to R into delta theta by. So this delta S by delta T is nothing but the instantaneous velocity of magnitude. So that becomes R into delta theta by delta T, which is the angular velocity. Okay. So this will become whatever radius. Now radius in the question was given to me as it's moving in question 11. Length of the string holding is 0.7 meters. So the radius is 0.7 meters. Okay. So this will become 0.7 meters multiplied by this angular velocity, which is 6 pi radians per second. Okay. So it will become 6 into 0.7, so that is 4.2 pi. And the unit will become meter per second because radian is a dimensionless quantity. So this will become the speed will be taken. And then you will have to just approximate this is approximately 4.2 into 3.14. Or you can approximate it as 4.2 into 22 by 7. That will be easier here. So that will become 0.6 into 2.2. So 13.2 meters per second. So that is your speed. So that is the 11th question. But don't worry, we will be doing circular motion in more detail later. So you will understand this relationship in more detail later. The angular speed is the rate at which angle is covered with respect to time. Okay, so angular speed is defined as angular displacement. Its rate of change of angular displacement with respect to time. So it is the angle covered delta theta divided by the time interval delta. Whereas linear speed is delta S by delta T, where delta S is the distance with respect to time. Is delta theta is the angular displacement, the angle the particle is covering in a time delta T. So Anshul, hope this is clear. The relationship between angular speed and linear speed comes from the radius. Okay, so moving on. Now the next question I want to cover is an interesting one. Where is it now? Just a moment. Question number 7 of exercise 4. So come to page 25. Page 25, question number 7. Okay, try this out now. So you have a truck that starts from rest at t equal to 0, but with a uniform acceleration, let's say a1 of 1.5 meters per second. So at that same instant of time, there's a car somewhere behind it which starts a car which also starts at t equal to 0 only, with a uniform velocity and all that. So with a uniform acceleration and all that, starting from rest. But this one has an acceleration, let's say a2, which is, how much is this now? 2, is it? Yeah, 2 meters per second square. And this is 150 meters behind. So at some later time, it's at some time t, the car is going to overtake the truck. This is at some time t, the car overtakes the truck. So you have to calculate how much that time is. Just work this out quickly. Very easy question. Or they are side by side. So overtaking, you can say the car and truck are side by side. Adina, you are calculating what quantity here, because you have to calculate the time beta. So it has to be in seconds or minutes or something like that. No? Okay. Yeah. Okay, good. So you can go with two approaches here. One is the approach of relative motion at dot. Okay. So if you look at the motion of the car relative to the truck, that makes life very easy actually. So as an observer, you are sitting inside the truck. So in your frame, what you are seeing for the car is that at t equal to 0, the car was somewhere here, and at some time it has come alongside me. Now t equal to t, the car is here. So this is the displacement of the car with respect to the truck in that time. Yes, Aparna, correct. Good. Whereas we know that this is 150 meters. So we can see that with respect to the truck, the displacement of the car with respect to the truck should be equal to plus 150 meters in time t. Okay. Now we can also see that, just a second, I'll reshare the screen, just give me a second. Yeah, Bhagyashri, correct. Just a moment, people. Yeah, so you should be getting the whiteboard again. Okay, now, so again, you can see here that what is happening is that at t equal to 0, the initial speed of the car was 0, the initial speed of the truck was 0. So with respect to the truck, what we can say that at t equal to 0, the initial speed of the car with respect to the truck is also 0, because we have this relation that velocity of A with respect to B is velocity of A minus velocity of B. So here both are 0, so the relative is 0. Okay? But the acceleration of the car is plus 2, whereas the acceleration of the truck is plus 1.5 meters per second square. So again, same relation holds for acceleration. Relative acceleration of A with respect to B is acceleration of A minus acceleration of B. So here, the acceleration of the car with respect to the truck will become plus 2. This is the car's acceleration minus plus 1.5. That's the truck's acceleration. So it is plus 0.5 meters per second. So the relative acceleration of the car with respect to the truck is 0.5. Whereas the initial velocity of the car with respect to the truck is 0. So how we can write displacement as a function of time? Ut plus half at square. So the displacement is equal to ut plus half at square. But only here, which displacement we are talking about? Relative displacement. So which initial velocity? Relative. Which acceleration? Relative. So everything is relative. Okay? So this thing should be equal to plus 150 at a time of t. So from here we will get the time as square root of 4 into 150. So that is 2 into square root 150. This will come out to be 24.5. So that is your solution of this question. or you can also write this as square root 600 or 10 root 6. So from that also you can see that. Okay, so hope this is clear. Okay, so hope this question is clear, people. So I think we have time for one more question before we conclude today. So let us do this question number 14, the same exercise. Page 25, question number 14. Okay, anybody got the answer? Has anybody got the answer, please, of question number 14? Okay, so in question 14, see what it's saying, that it is traveling a displacement of 10 meters in the first 5 seconds. In the first 5 seconds. Okay. So first 5 seconds kya hai basically? It is t equal to 0 to t equal to 5 seconds. That interval of time. And then it is traveling a displacement, let's say s prime, but again of 10 meters in the next 3 seconds. So next 3 seconds कौन सा interval of time है? It is from t equal to 5 seconds to t equal to 8 seconds. So from 5 to 8, it is traveling a displacement of again 10 meters. Acceleration is uniform. It's a uniformly accelerated motion. So we have to find the displacement, let's say S double prime, in the next 2 seconds. Right? Next 2 seconds. You'll understand distance and displacement are same here. Because it's motion along a straight line with positive acceleration. Because it's covering the same distance in less time. So that means the speed is increasing. So there's no chance of the direction reversing. Okay. So how we'll do this question, see, we have two unknowns. We have u is not known, initial velocity, and acceleration is not known. So we need two equations are needed. So the first thing we can see here is that the displacement is equal to 10 meters from t equal to 0 to t equal to 5 seconds. So use that. So s is equal to ut plus half ut square. इसमें टाइम को क्या सब्स्टिट्यूट करेंगे 5 सेकंड्स और डिस्प्लेसमेंट को क्या सब्स्टिट्यूट करेंगे 10 मीटर्स. ओके, सो 10 is equal to 5t plus 25 by 2t. So this is becoming my equation 1. Okay. Now the displacement is again 10 meters, but from t equal to not 0, rather t equal to 5 seconds to t equal to 8 seconds. In this interval of time, it's 10 meters. So now what we can use here is we can use the fact that from 0 to 8 seconds in this time interval, what is the net displacement? It is 10 plus 10, 20 meters. Is this point clear to all of you? अगर पहले 5 seconds में displacement is 10 meters and then next 3 seconds में the displacement is 10 meters again. This is the next 3 seconds. This was the first 5 seconds. So that means what is the total displacement after 5 plus 3? That is 8 seconds. 0 to 8 seconds, the net displacement is 20. So again, we will use which equation? We will use this displacement equation here. But we'll use this with this data. Okay, so this will give us that 20 is equal to u into 8 plus half a into 8 square. So we get 20 is equal to 8u plus 32e. So that becomes my second equation. And this was my first equation. So now these two equations can be solved and we can find out the value of u and a, and from that we can find out the displacement. Okay. So this is clear now. So solve this for u and a. So you can see solving for u and t. You can see that we had 5u plus 25 by 2a was equal to 10. That was equation 1. And we have 8u plus 32a is equal to 20. That's equation 2. So what we can do is we can multiply this whole equation by 8, okay, and multiply this whole equation by 5 and subtract the 2. So we will get how much here? We will get 25 into 2 into 8. 25 by 2 into 8a minus 5 into 32 is equal to 80 minus 100. Or we can write this as 160 minus 100 a. I've just flipped the sign, is equal to 20. So a is equal to 1/3 meters per second. And then substitute this in equation, whichever you like, in equation 2. So we will get 8u plus 32/3 is equal to 20. So u is equal to 20 minus 32/3 1. So u will become 1/8 into 60 minus 32, so that is 18. So it is 28. So this is 7/6 meters per second. Over u and over solving. Now you can find the displacement at t equal to 10 seconds. कितना हो जाएगा? So you can find this displacement, and now whatever this displacement is coming out, you can find out the displacement from 8 to 10 seconds. It will become the displacement after 10 seconds minus the displacement after 8 seconds. So this one is the displacement at 10 seconds. And the displacement at 8 seconds was 20 meters. We calculated that earlier. From that, you will get the answer. Okay. So this is the method for solving the question. The main thing is solving equation 1 and 2 to get the value of u and v, which you have to do this way. Oh, good. Okay, people, so hope this is clear. So with this, I'm concluding today's lecture. I will share the whiteboard PDF notes and the recording, so you can see the calculations in more detail in that. But that's it for today's lecture, people, and I'll send you a list of some of the questions you can try out for homework yourself from this, from these exercises. So we will do a few more questions next time, but eventually we'll now move on to Newton's laws of motion after finishing some more questions. Okay. That's it for today's class, people. All the best and stay safe.